This video will provide a basic introduction into stoichiometry. And for most chemical reactions, there's basically three types of conversions that you need to concern yourself with. The first type, the shortest one, is to convert the moles of substance A to the moles of substance B. And you need to identify the molar ratio in order to do that. Number one is going to focus on that problem. The second type of problem is to convert the moles of substance A to the grams of substance B. Or you could be given the grams of substance A and you need to convert it to the moles of substance B. So that's the second type of problem that you'll see. The third type is if you're given the grams of substance A and you need it to convert it to the grams of substance B. So this involves, I believe, 3 steps, and this one 2 steps, and the first one is a single step. So let's begin working on these problems. Number 1, sulfur dioxide reacts with oxygen gas to form sulfur trioxide. If 3.4 moles of sulfur dioxide reacts with excess oxygen gas, how many moles of sulfur trioxide will form? The first thing that we need to do is we need to write a balanced chemical equation. Sulfur dioxide is SO2. Oxygen is diatomic, it's O2. And sulfur trioxide is SO3. So now we need to balance it. The sulfur atoms are balanced on both sides, but we have 4 oxygen atoms on the left and 3 on the right. So let's start by putting a 2 in front of SO2. So now we have 2 sulfur atoms, which means we need to put a 2 in front of SO3. Now it turns out that the number of oxygen atoms on both sides is now 6. On this side, 2 times 3 is 6. Here, 2 times 2 is 4, plus another 2, that's 6. So we have a balanced chemical equation at this point. Now, we're given 3.4 moles of sulfur dioxide, and we want to convert it to the moles of sulfur trioxide. So what we need to do is use something called a molar ratio. The molar ratio between sulfur dioxide and sulfur trioxide is 2 to 2. So what this means is that for every 2 moles of sulfur dioxide that reacts, 2 moles of sulfur trioxide will be produced. Now, since we have moles of SO2 on the top left, we need to put that on the bottom right so that those units will cancel. And the other 2 moles of SO3, we could put that on top. So whenever you want to convert from the moles of substance A to the moles of substance B, all you need is 1 additional fraction beyond what you're starting with, and you'll get the answer. 2 divided by 2 is basically 1. So the answer is 3.4. Since the molar ratio, the coefficients are the same. The molar ratio is 1. And so this is the answer for part A. Based on this example, go ahead and try part B. How many moles of oxygen gas will react completely with 4.7 moles of sulfur dioxide? So let's start with what we're given, which is 4.7 moles of SO2. Now, we need to convert the moles of SO2 to the moles of oxygen gas. So it's a one-step problem. All we need is 1 additional fraction. So we need the molar ratio between SO2 and O2. So for every 2 moles of SO2 that reacts, 1 mole of oxygen gas reacts along with it. So let's put the 2 moles of SO2 on the bottom, but on the top we're going to put 1 mole of O2 based on the coefficient in front of it. So make sure you balance the chemical equation before starting this problem. So the answer is going to be 4.7 divided by 2, which is 2.35 moles of O2. As you can see, it's not that difficult to convert from the moles of one substance into the moles of another substance. Number 2, propane reacts with oxygen gas to form carbon dioxide and water. Part A. If 2.8 moles of propane reacts with excess oxygen gas, how many grams of CO2 will form? So let's write down what we need to do. We're given the moles of propane, C3H8, and we need to convert it to the grams of carbon dioxide. So basically, we have the moles of substance A, and we want to convert it to the grams of substance B. So it's a two-step process, so let's take it one step at a time. So starting with the moles of A, you want to use the molar ratio to change it to a different substance while keeping the unit the same. The unit is moles, the substance is A. So you want to change one thing at a time. In this first step, we're changing from substance A to substance B. Now that we have substance B, we could change the unit from moles to grams. So it's a two-step process for this problem. Now, before we can begin, let's write a balanced chemical equation. So we have propane, C3H8. It reacts with oxygen gas to produce carbon dioxide and water. So we have 3 carbon atoms on the left. Therefore, we need to put a 3 in front of CO2. And there are 8 hydrogen atoms on the left and 2 on the right. 2 times 4 is 8, so let's put a 4 in front of water. Now 3 times 2 is 6, so we got 6 oxygen atoms from the 3 CO2 molecules. And 4 times 1 is 4, so we have 4 oxygen atoms from the 4 water molecules, giving us a total of 10 oxygen atoms on the right side, which means we need 10 on the left. 10 divided by 2 is 5, so therefore we need to put a 5 in front of O2. So now we have a balanced chemical equation. Now in part A, we're given 2.8 moles of propane. So first, we need to convert or change the substance from propane to carbon dioxide because that's what we're looking for. So let's use the molar ratio to change the substance. So the molar ratio between propane and carbon dioxide, it's 1 to 3. So for each mole of propane that reacts, 3 moles of CO2 will be produced in this reaction. So we could cancel these units. Now, we can convert from moles of CO2 to grams of CO2. So we need the molar mass of carbon dioxide. So CO2 contains 1 carbon and 2 oxygen atoms. So that's 12.01 plus 2 times 16, which is going to be 44.01. So 1 mole of CO2 has a mass of 44.01 grams. So whenever you see this number, the molar mass, the units are grams per mole. So 1 mole of that substance has a mass of 44 grams. So now let's just do the math. So we can multiply across. It's 2.8 times 3 times 44.01. And so I got 369.7 grams of carbon dioxide. So that's it for part A. Now let's move on to part B. Feel free to pause the video if you want to try it. It's very similar to part A. How many grams of oxygen gas will completely react with 3.8 moles of propane? So we need to convert moles of propane ultimately to grams of oxygen. So we're going to follow the same steps. First, we need to change the substance from propane to oxygen, but keeping the unit the same. So we need to use the molar ratio to change the substance. After that, we could use the molar mass to convert from moles of O2 to grams of O2. So that's the blueprint of what we need to follow. So let's start with what we're given. That is 3.8 moles of propane. And let's use the molar ratio to convert it to moles of O2 to change the substance. So the molar ratio is 1 to 5. So 1 mole of propane, C3H8, will react completely with 5 moles of O2. So now we're at this point. So we need to use the molar mass to go from moles to grams. Now, the atomic mass of a single oxygen atom is 16. So the molar mass of an oxygen molecule that has 2 oxygen atoms is 2 times 16, or 32. So it's 32 grams per mole. So what that means is that 1 mole of O2 contains a mass of 32 grams. Now we can get the answer. So it's 3.8 times 5 times 32. And so it's 608 grams of O2. So that's the answer for part B. Now let's move on to part C. If 25 grams of C3H8 reacts with excess oxygen, how many moles of water will form? So this time, we're given the grams of C3H8, and we need to convert it to the moles of water. So we're given the grams of substance A, and we need to convert it to the moles of substance B. So first, we need to change the unit. We need to go from grams to moles, and we're going to use the molar mass to do so. And then we're going to use the molar ratio to change the substance from A to B. So in our particular example, we're going to convert the grams of propane to the moles of propane using the molar mass of propane. And then we'll use the molar ratio to change the substance from propane to water. So basically, part C is the reverse of A and B. So let's begin. Let's start with what was given to us in the problem. That is 25 grams of propane. Now we need to find the molar mass of propane. It has 3 carbons and 8 hydrogens. So that's 3 times 12.01 plus 8 times 1.008. So that works out to be 44.094 grams per mole. So 1 mole of propane has a mass of 44.094 grams. So we could cancel the unit grams of C3H8. So now let's use the molar ratio to change the substance from propane to water. So the molar ratio is 1 to 4. So for each mole of propane that reacts, 4 moles of water will be produced. Now let's perform the operation. It's 25 divided by 44.094 times 4. So this is about 2.27 moles of H2O. And that's the answer. Part D. If 38 grams of water are produced in the reaction, how many moles of CO2 were produced? So this time we're given the grams of water, and we need to find the moles of carbon dioxide. So just like before, first we're going to change the unit from grams to moles using the molar mass. And then using the molar ratio, we're going to change the substance from water to CO2. So let's begin. If you want to pause the video and work on this problem, feel free, go ahead, because the best way to learn is through practice, by taking action. So let's start with 38 grams of H2O, and let's convert it to moles. So we need to find the molar mass of water. So we have 2 hydrogen atoms plus an oxygen atom. Each hydrogen atom is 1.008. We got to times that by 2 and then add 16 to it. So the molar mass of water is 18.016 grams per mole. So 1 mole of water has a mass of 18.016 grams. So now we can move on to our last step, and that is converting moles of water to moles of CO2. So the molar ratio is 3 to 4. So for every 4 moles of water that are produced in this reaction, 3 moles of carbon dioxide are produced along with it. So it's going to be 38 divided by 18.016 multiplied by 3 divided by 4. So the answer that I have is 1.58 moles of carbon dioxide. And that's the final answer. Number 3. Aluminum reacts with chlorine gas to form aluminum chloride. Part A. If 35 grams of aluminum reacts with excess chlorine, how many grams of aluminum chloride will form? Let's start with the reaction. So we have aluminum reacting with chlorine gas. Chlorine is diatomic, just like oxygen gas. And when combined, it's going to form aluminum chloride. Now we need to write the formula of aluminum chloride. How can we do so? Aluminum has a positive 3 charge. Chloride has a -1 charge. So using the crisscross method, it's going to be Al1Cl3, or simply AlCl3. Now before we begin the problem, we need to balance the chemical equation. The number of chlorine atoms is not the same on both sides, but the number of aluminum atoms, they're equal on both sides. So we got 2 on the left, 3 on the right. What I like to do is find the least common multiple of 2 and 3, or just multiply 2 and 3, which is 6. So to make them equal, I need 6 chlorine atoms on both sides. So I'm going to put a 3 in front of Cl2, that's going to give me 6, and a 2 in front of AlCl3. So now I have 6 chlorine atoms, but I now have 2 aluminum atoms on the right side, so I got to put a 2 on the left. So now we could focus on part A. If 35 grams of aluminum reacts with excess chlorine, how many grams of aluminum chloride will form? So this is a gram to gram conversion. We need to convert the grams of substance A to the grams of substance B. Now there are 3 steps that we need to perform to complete this process. First, we need to change the units from grams to moles. So we need to go from grams of A to moles of substance A. And we need to use the molar mass of substance A to do that. Next, once we have the moles, we need to change from substance A to substance B. So we need to use the molar ratio for that part. Finally, now that we have the moles, we need to change the unit from moles to grams using the molar mass of substance B. So there are 3 steps that we need to take. This is step 1, step 2, step 3. So in our particular example, we have the grams of aluminum, and we need to convert it to the moles of aluminum. Next, we're going to use the molar ratio to convert it to the moles of, I'm looking at the wrong problem. Part A, we still have the grams of aluminum, but we need to convert it to aluminum chloride. So we got to get the moles of AlCl3 next. And then finally, we can convert that to the grams of aluminum chloride. So that's an overview of what we need to do in this problem. So let's start with what we're given. That is 35 grams of aluminum. Based on the periodic table, the atomic mass of aluminum is 26.98. So that means 1 mole of aluminum has a mass of 26.98 grams. Next, we need to change the substance from aluminum to aluminum chloride. So the molar ratio is 2 to 2. So for every 2 moles of Al that reacts, 2 moles of aluminum chloride will be produced. Now the last thing that we need to do is we need to change from the moles of AlCl3 to grams. So we got to find the molar mass of AlCl3. So we need to add the atomic mass of one aluminum atom with 3 chlorine atoms. So this is 26.98 plus 3 times the atomic mass of chlorine, which is 35.45. So this is equal to 133.33 grams per mole. So 133.33 grams of AlCl3 is equivalent to 1 mole of AlCl3. So now let's do the math. It's 35 divided by 26.98. 2 over 2 is 1, so we could cancel the 2's if we want to. And then let's multiply by 133.33. So the final answer is 172.96 grams of aluminum chloride. So that's the answer for part A. Part B. How many grams of chlorine will react completely with 42.8 grams of aluminum? So feel free to try that problem. So we have the grams of aluminum. Next, we need to change it to the moles of aluminum. And then we're going to change the substance using the molar ratio to moles of chlorine. And then finally, well, chlorine's diatomic, so this is Cl2. Next, we'll change it to the grams of chlorine. So that's a gram to gram conversion. So let's start with 42.8 grams of aluminum. And let's convert it to moles using the same atomic mass, which is 26.98. Now let's use the molar ratio to change it from aluminum to Cl2. So it's 2 to 3. So for every 2 moles of aluminum that reacts, 3 moles of chlorine gas reacts with it. Now we need to find the molar mass of Cl2. It's going to be 35.45 times 2, which is 70.9. So 1 mole of Cl2 is equivalent to 70.9 grams. So always make sure the other units cancel out. If they don't, then there's a mistake somewhere. So now let's finish the problem. It's 42.8 divided by 26.98 multiplied by 3 divided by 2 and then multiplied by 70.9. So the final answer that I have is 168.71 grams of chlorine gas. So now you know how to perform a lot of conversions associated with stoichiometry. You know how to perform a mole-to-mole conversion, which we covered in problem 1. You know how to go from the moles of one substance to the grams of another, or the grams of one substance to the moles of a different substance. And you know how to perform a gram-to-gram conversion as well. So these are common stoichiometry problems that you might see in a typical chemistry class. So thanks for watching and have a good day.